So in this lesson, what we're going to do is we're going to go back and look at Ohm's law, and we're going to look at series and parallel calculations. So just as a recap, Ohm's law is where we relate voltage. So voltage equals current times resistance. So that appears in the data book as V equals IR. And you should be able to rearrange that to give us I equals, and to give us R equals. So if it was I equals, the R goes over the other side, but if it's multiplying on this side, it will be dividing on that side, so it's I equals V over R. And it's the same for the R, the I needs to move over the other side of the equal sign away from the R. If it's multiplying on this side, it will be dividing on the other side. So those are the three forms of Ohm's law that we would use, okay? And we would use them, I realise I've spelled resistance wrong. We would use them whenever we're looking at a resistance, whenever we're looking at a particular part of a circuit. So if you're given a circuit with a power supply and you know that there's a bunch of elements in there, there's just the series element. Ohm's law holds true at that resistor, and it also holds true at this resistor. So if I tell you that that's 6 volts, and I tell you that that's 2 kilo ohms, you should be able to use your knowledge of Kirchhoff's law, or your knowledge of resistance laws, or your knowledge of Ohm's law to work out everything else about that circuit. So you should be able to tell me how much current is being drawn from supply, IT. You should be able to tell me what the, because this is a series circuit, you should immediately recognise that the current through that resistor will be IT, and the current through this resistor will be IT, because it's a purely series circuit. But you should also be able to tell me what the voltage drop here is, and you should also be able to tell me what the voltage drop here is, and call that V1 and V2. And you would do that using a mixture of Ohm's law and resistance theory and Kirchhoff's laws. So we've already covered all of these things so far. Just in case, I'm going to say a couple of questions, or maybe 5 questions or so, where it's just using Ohm's law, either that one, or that one, okay? And then we'll look at how we do it in a circuit, because you've then got a bunch of laws to choose from. So let me set up a couple of questions on Ohm's law on its own. Okay, so here's 4 badly drawn questions. In each case, there's something missing. I'm going to indicate on red what it is you have to find. And all you're doing is using V equals IR and then rearranging it. So in this one, you've got a simple circuit with a voltage supply and a resistance. You know the current and you know the resistance, and you're looking for what must the supply voltage be then. So if you had a load of 6K2 and it had 4.3 amps going through it, what must the supply voltage be? And you can Ohm's law, V equals IR, to find that out. In question 2, I've put 2 resistances in, and all I'm doing is asking for the 2 individual voltages this time. Should maybe do these in a slightly different, we'll do them in this order. So there's 2 voltages to work out. So you're going to use Ohm's law twice. Let's call it V1 and V2. This is a series circuit. So that as I said in the previous example, that 1.7 amps flows through both of them. So the current through that 2K resistance is 1.7 amps. So you've got a resistance and you've got a current. So you can work out the voltage across this. When you do the equation a second time in this circuit, it will be different, because as much as the current is the same, the resistance is different. So that's why you'll get 2 individual voltages. You already know Kirchhoff's second law, so you should realise that V1 and V2 must add up to 6 volts. You may get a wee rounding error in there, so don't worry about it. You should get something really, really close to 6. What you could do is, you could use Ohm's law to work out V1, use Ohm's law to work out V2, and then check. Use Kirchhoff's second law to check that you're correct. Or you could do it the other way. You could use Ohm's law to work out V1, and then you could use Kirchhoff's second law to work out V2, and then you could use Ohm's law down here to check that you're correct. So, but it's still Ohm's law, and you're still using V equals IR in questions 1 and 2. In question 3, what's missing is the resistance value. So you're not calculating voltage this time, you're looking for a resistance. You've got the current through the resistance, and you've got the voltage across the resistance. So you've got I and V, and you're looking for R. So you need to rearrange the equations to state V equals IR, rearrange the equation to R equals, and then plug in the numbers and get your answer. Remember this, remember your units. Your units should be volts, amps and ohms. So that's 6K2 is 6.2 thousand, so that's 6,200. Don't use 6.2 or any other equivalents, it's 6,200, okay? And then in this last one, it's the current that's missing, so it's I that you're looking for in this one. IT in this case. So you've got a resistance 1,700 and you've got a voltage 9.4 volts. That's 9.4 volts, by the way. Let me just clarify that. So there's 4 questions on Ohm's law on its own, okay? What I'm then going to ask you to do is to use, so see these 3 questions here where there's one resistance. What you need to remember is that you could be faced with a complex circuit that's got series and parallel components in it, and you should be able to reduce that circuit down to one equivalent resistance. You should be able to use your knowledge of how to treat resistances in parallel and resistances in series to break it down so that you end up with a circuit that looks like that, like a circuit that looks like the circuit in question 1, 3 or 4. In fact, you could do it over here as well. You know, you could take that, actually I'll need to redo the numbers on that, give me a second. Right, so I'm just changing these numbers to make it accurate. Right, so that's true. Right, so yeah, you could, I kind of lost my train of thought there. So yeah, you could reduce this circuit. You could do your series resistance law and bring that down to one resistance, and then calculate the voltage drop across it or whatever. I don't know why you would do that, because you already know the current and you already know the voltage. But if you wanted to prove it or whatever that circuit's true, you could. You could take that 5,900 and that's 600 volts and calculate the current, and you would find that it was 1.07. But you'd have to use the series resistance law first, and that's what I'm going to ask you to do. So I'm going to set up another maybe 5 questions that are a little bit more complex. Let me have a second, I'll set them up, we'll talk about them. Right, okay, so here's another 3 questions, but this time they are not as simple. So in the first circuit it's purely series, in the second one it's purely parallel, and in the third one the 1K9 is in series with these two in parallel with each other. What I want you to calculate are all the currents and all the voltage drops. So I need you to calculate for question 1, I need IT, I need V1, and I need V2. Okay? Because once you work out IT, that is the current through those resistances. Over here, we don't have to work out the voltage drop across the 2K4 or the 1K2 because it's 11 volts. Alright? But you will have to work out IT, and then you'll have to work out I1, and you have to work out I2. Now what to do is remember, you know, how you would do this. So find the total resistance, draw the circuit. Suddenly it's going to look like that. Yeah, it's going to look like just a power supply with a resistance, a really simple circuit. And then you can use that resistance in the power supply in Ohm's law to work out the current. And then once you've got the current getting in here, you know the voltage across the 2K4, it's 11 volts. So you've got 11 volts in 2K4, you can work out the current. You can do the same here, 11 volts in 1K2, use Ohm's law to work out the current. Check that they add up to IT. Alternatively, you don't need to work out the total resistance, you could use the voltage drop and the resistance to work out I1, the voltage drop and the resistance to work out I2, and then you could add them up and that would give you IT. And then in this circuit, it's a little bit more complex. So in this circuit, I need you to tell me the voltage drop here. I need you to tell me what the voltage drop is across the parallel branch V2. So whatever voltage you work out over the 6K2 resistor is going to be the same as the voltage over the 3K2, the 3K4. Because remember, and when you've got a parallel circuit, they all get the same voltage. That's why this is solely parallel. They've both got 11 volts across them, both get supply. Over here they don't, because there's a series element. Okay, so V1 and V2 are different. I need you to tell me IT, and I need you to tell me I1 and I2. So you get everything to work out in this circuit. But it's the same deal. Work out the parallel resistance. That gives you a circuit that looks like that. Work out the series resistance. That gives you a circuit that looks like that. You'll have this resistance and you know this voltage. So you can work out IT, and that will be the current here. You can then use Ohm's law to work out V1. You can then use Kirchhoff's law, subtract V1 from 16, that gives you V2. Once you know V2, you can use Ohm's law, the 6K2 and the V2, to work out I1. You can use Ohm's law, the 3K4 and the V2, to work out I2. Get I1 and I2 together to make sure it adds up to IT. You can add V2 and V1 together, make sure it adds up to 16 volts. That's the process. Now you can watch and rewatch this video to hear those hints again in order to do the questions, okay? That's all I want you to do today, and then we'll check that and then we'll see how you do. Thank you very much.